Andrea, so it's your talk is really famous. Okay, decorators and context manager, Andrea Crotti. It's your turn.
So, hello everyone. I'm Andrea Crotti. I work in London for a startup called Wasoku, and you can find all the slides and the code that we show in this GitHub page. I will show this link also later in the end, so you can copy that. Let's start. So first of all, I will talk about decorators, and in the end, I will explain something about context managers. I put these two topics together because they are two. I think they are two very nice syntactic sugar things, Python, that allow you to write better code and more readable code. Some background first. In Python, as you probably know, every function is a first-class object, and the type of every function is function. And the same way, every class is a first-class object, and the type of a class is type. So I will do a lot of live coding, and I will show a lot of things in IPython while I code, because I like you to see I'm not cheating and I'm not saying something that is not true. So for example, now I just go here. I can close this, and then I just define a function a b with some turn a plus b. I can do type function, and then I can inspect this function. I can see the code. This is a code object. Inside the code, I can see what is the name of the function. I can see many things. So I can modify and inspect anything. The same thing for a class. If I define a class, to pass the type of a class is type, and the same way I can access to it's just a normal object. So let's go back to this. Having said that, a decorator in Python is a callable that takes a function or a class as an argument and returns a function or a class with possibly altered behavior. The syntax, the at syntax, was introduced for functions in Python 2.4 and for classes in Python 2.6. But I think the most important thing to understand is that the at is just syntactic sugar for something you could always have done anyway. First of all, let's see a very simple example of what can look like, a decorator can look like, and what allows you to do. This is the simple, stupid, recursive Fibonacci function, which you probably all know. And then I will implement it in the standard way, and then I will add just one line on top, and the same algorithm. Exactly the same algorithm. And then I can do some simple benchmarking, and I can see that in the simplest case, this recursive call is very slow, and it will potentially explode my stack, and I get a stack error. So when n is equal to 5, the advantage of using the memoized function, the decorated function, is just twice. But already with n equal to 20, the speed up, the ratio is at 3,000. That is because this memoized function, this memoized decorator, will cache all the intermediate results and will not compute everything. I will show later how this memoized can be implemented. This is just a short introduction. This is how a simplest possible decorator looks like. So we have a function which takes a function as an argument, and then it defines a sub-function, which by convention I just put an underscore in front of the name, which takes args and kw args. So it's generic, you can take any argument. And then here I can, the standard thing to do is to do something before, compute the result of the original function, do something after, and then return the original result. And this will have, and then I have to return this sub-function which I just defined. And we see why this is important. And now to use it, I just add a line on top, which is exactly the same thing as doing this. So I define a function, and then I say I redefine it, passing this function to this other function, decorator. So what that means, I can show you. What that means is that now my function is not anymore the original one, but it's something that has been altered and it's been wrapped around this decorator thing. So I think the first question that comes up normally with decorators is why do you need to do this strange sub-function, return it, apply? So it looks a bit strange in the beginning. But why can't I just do this? Pass the function and all the arguments, and then do something before, do something after, and so on. I could do that, but what that means is that at compile time, when I actually import it, it will run immediately, because this is again the same thing as this. So what that means is that here I call something at compile time, import time. And then you will run everything at import time, which is obviously a very bad thing. You should never run something as a side effect of importing a module. So that is why. Now another very simple example. I will show you live how you can implement something like this. So live.py. First, I want to implement a decorator which simply logs out what I'm actually running. So simple verbose logging. So I do this, then I do args, then I say print running function func. Result, I cache, I save the result. Then I do after I return the result, I return verbose, and that should be it. So now this verbose is a decorator, and if I can just do this verbose func. Now if I run it, here it is. I say it's running func function blah blah now, and then I am inside the function, and then I say after running. One thing which is important to notice is that if now I look at what func is with the IPython magic tools, I see that now it points to the verbose, to the underscore verbose function. If I look at the code, if I inspect the code, I don't know anymore what is func, because now it's like it's been wrapped into this closure. And the arguments have been catched the first time I call it, and then this is what gets executed actually. So one way to avoid this problem is to use wraps. So if I use wraps, is a decorator itself, which is imported from functools module. Which allows you to not lose all the information about what you're actually running. It saves, for example, the name of the original function and the docstring. So now if I do this again, and I save, I go back, and now I do again the same thing. I redefine this. And now I should see the func is the correct one. It goes to, it goes here. Now there is no docstring, so it's not saved, but the name of the function, for example, is saved. Func name, here it is. Okay, let's go back to this. So back to the memoization example. This is a very nice, I think it's a very nice example of what you can do in very few lines of code of Python. So this memoize takes a function and then initialize a cache with the empty dictionary in the beginning. Then the sub function. This is the most tricky part somehow, because we want to cache all the possible arguments that are passed and the result associated with the arguments that were passed. But the problem is that, of course, if you want to put something in a dictionary, it has to be immutable. So one very quick way of doing it is to create a tuple with the arguments and the string representation of the KW argument dictionary. I must warn you that this is not perfect 100% safe, because this it's not always possible to do this. No? In simple cases, it's fine. But 90% of the cases or more, it works perfectly fine. If you want to see a real implementation, a safe implementation of this in Python, from Python 3.3, I think, there is a LRU cache function, which is, the problem is that it's very, very long. So this is, because it has to do a lot of like frozen set, a lot of things that I'm not doing. Okay, but once I managed to freeze these arguments, then I can check if this key is in the cache. It's not in the cache, then I compute the function and I assign it. Otherwise, I just return it. Otherwise, I don't do anything, and then I just return the result. So this is how you can do in very few lines this thing. And this is generic because you can take any function, any argument, any argument, and you're fine. And this is what happens basically when you do that. With this very small input number, you don't see very much, but it's already enough to see what's going on. So first of all, I want to compute Fibonacci of 4, which expand to Fibonacci of 3 plus Fibonacci of 2, and the search is the depth first. So now I want to compute this, which goes here, and now Fibonacci of 2 goes here. And now I reach the case when I have just the two base cases, so 1 plus 1 plus Fibonacci of 2. And now at this point, I finally managed to compute the first actual element, which is Fibonacci of 2, which is now the base case. And so I can add it to the cache. This add the Fibonacci of 2 doesn't need to do again the same unfolding, the same recursive calls, because it just found in the cache. And so I save. In this case, I only save one call, but the number of calls that I save is exponentially increasing. Another thing, of course, is that in this simplest implementation, there is no limit of the RAM that you're going to use, because it's. But that's also relatively easy to add. So what do you do when you want to have parameters in your decorator? So it becomes a bit more tricky, because you need actually two nested functions. The first one is the one that takes the parameters you want to pass, and then the two nested functions are just the same as before. And we can see an example of how that looks like. But another way to do the same thing, which I think is more clear because I don't like to nest too much, is to use the underscore call method. So you can have a class, and then which takes as parameter here of the initializer do it equal to false, for example, and then it defines this underscore call, which is the same as before, basically. The reason why you can do that is that decorator doesn't have to be a function, it just only have to be a callable. And whenever you define underscore call in an object, then it becomes automatically a callable. So this very simple decorator doesn't do really much anything interesting. What it does is to check if you actually want to do something or you just want to simulate it. And so if I want to, I can show you how it works. So I do import deck. Set param deco class. Okay, I just pass a parent deco, not sure why. Okay, and then I say do it. If I don't want to do it, say false, not running. And this should not run. Parent deco. I think I'm not using the right module. Okay. Okay, yes. It's not. It didn't run. This is just the output from the decorator itself, but the function didn't run. If I do it again and I pass do it equal to true, and now it runs. Okay. So this is how you can define a parametric decorator. If you have any questions in the meanwhile, or I'm going too fast, please tell me. This is another decorator which I wrote in my 2 jobs ago. And this was used to allow you to repeat the same action more than once in case it was failing with the limit and the timeout. So what happened is that we had a very flaky connection with Perforce, or I don't know what it was, something. So we had to repeat it until actually succeeded. It's not the best thing in the world, but there was. And so everywhere in the code, all around the code, there were these things like hard-coded, I try, okay, it didn't work, try again, sleep. So I decided that I had enough of that, and then I wrote this simple decorator. What it does is that it initializes the number of attempts to 0, and then it checks if it's less than number of maximum times I can try, and then it computes it. If there is an exception raised somewhere, then it sleeps, and then it goes back to the while loop, and after incrementing the number of attempts. Otherwise, if it goes out of the loop, then it will not run anything, basically. It will not return the result. I can show you very simply how also that works, in case you don't believe me. If I just try with something, say timeout equal 1, and then times equal 2, def failing. So something that always fails, for example, set false. This will try twice, and then it will not do anything. If instead I want to say it's working first time, and now I do it again, it works. So yeah. A more interesting example, of course, is to show something that fails the first time and doesn't fail the second one, but it's a bit more tricky to do live, so I will skip that. Another thing which I said in the beginning is the class is a class decorator. So you can do the same thing that you do with functions with classes. This is a way of doing metaprogramming without all this underscore new, and it can be useful sometimes. What I can do, for example, is to add a method to a class without subclassing anything. So I just define this class decorator, which takes a class object, and then defines this new method inside, which, as you can see here, self is not bound to anything, but it will be bound when you actually have an object. So here I just assign this new method to this thing, and then I return it. So when I apply this class decorator here, magically I will have this method available. So I can show you again now. So if I do like class decorator class G class, as you can see here, I'm not defining anything, but here I have new method. If I run it, it doesn't work. Oh no, yes, because I have to do an instance. Okay, it works. So if I look at the code, here I still have the same problem because I don't see, yeah, just a normal class. And a nice example where this thing is used, I think, is in the mock library, which I think you use. You can patch, when you patch a function in the mock library, it will replace at runtime something with something else that you define there. Here, I don't want to run this x.module.function, and instead I want to run lambda. I want to just run a function that takes something and returns 42. But if I do it at this level, what it will do is it will automatically inspect the class, all the methods, and patch all the methods of the class. So this is a very neat way to use for unit tests, for example. Now let's change topic. Well, one last thing I want to say about decorators is that you should not overuse them, because they make life a bit harder to debug sometimes. Especially if you don't use wraps. And another important thing is that the order of which you apply them is important. So depending on if you write the decorator correctly, it shouldn't matter, but it can make a difference. So just be aware of this. Now let's switch topic. Let's go to the context managers. And they were introduced in Python 2.5 with the with statement, and they're very useful whenever you have something like a pattern, set up something, do something else, and then tear down to clean up some state, for example. So this is just syntactic sugar again, and to do something in a way that is more readable to me. And for example, here is exactly the equivalent as this. Here I say with open file as source save something. Automatically, at this point, when I de-indent again, this file will be closed. If I don't use this form, then I have to close the file myself here. The problem is that here there can be a lot of stuff, and then I can easily forget about this. So I think that's why they're nice to use. To implement a context manager yourself, there are a couple of ways. The first way is to implement the enter and exit methods. What happens is that you just create a class. This particular thing creates a temporary file with the content that you want, and then and potentially the path where you want to create it, and then remove it when it's done. So in the enter function, you will actually create the file, it will write the content, and then it will return something that will be possible to use inside the body. And then in the exit, it will simply remove the file. I can show you how you can use this. Port context file. So I can say with context temp file, and I say content equal to hello EuroPython. And then I say as temp file path, for example. Say print temp file path. Right. Okay. So this was the path of the file which contained the string hello EuroPython. If I now try to look at this thing, it doesn't exist anymore. ENQU. SR, yeah, because it was removed. But if I now try to say also open temp file path, read, God, open temp file. I made a mess with the indentation. Okay, yeah, it printed out something, which is what we were containing. So, yeah. Another important thing is that the exit method will take 3 arguments. It takes type, value, and traceback. And these arguments are used if in the body of your context manager, in the with body, if you raise an exception of any kind, you will have this available in the exit. So you can decide, for example, to just filter them. If it returns true, if the exit returns true on some condition, then it will simply ignore an exception, for example. You can say well, I don't have an example about that, but you can say return is instance in the exit, is instance, is instance value type error, for example, in the underscore exit, and it will just ignore the type error. Another way of defining this is to use the context manager decorator from the context lib, which is very neat way to do it. And this way works in a different way because it uses yield, so it's like you have to write a generator. How it works is that it will run as a setup action anything you do here. So you just define your context manager by writing here the setup actions, writing here your tear down actions, and then in the with body do this. This is how I can define, for example, a simple HTML tag context manager, which will automatically print me the H1 here, H1 here, and then in the middle I can do whatever I want. It's not just this. I can do other things, but I'm sure that the tag will be always closed correctly. So I suggest you to look at this if you want to use context managers. And that's all. Yeah. If you have any questions.
Question time? Questions?
Hi, thank you for the great talk. When you showed the patch thing in the decorator, I was just wondering, is it recursive? Is it able to go into the calls? I mean, you told us that it patched basically the methods of the current classes. And then does it go deeper?
I don't think so. I didn't check. I don't think it makes sense to go deeper because it's
local, basically.
Well, it's every method of the class that you are decorating.
It doesn't change the general environment.
No. This is. I mean, the good thing about this patch thing is that it will change the behavior of something, and then it will change it back. So, in the context of this class, for every method, it will be changed. But for every anything else running on this module in this file, or anywhere else, it will be still the same function.
And how do you use it?
How do I use it?
Well, what are the use case, in fact? Because you're in a test in this case, so.
Well, I have many possibilities maybe to show. I should look for something. Patch. Let me see. Right. Well, this is from code from my company. So, for example, here I have. So here I have something unit testing Elasticsearch, which is important because I still don't understand how it works. So I need to have some tests. And then I have a function which says company name to DB, which returns me something, but I don't want to actually call this function because it doesn't make sense, and because I'm using a test index. So in all this function, get test lookup with malform field test get documents. This function, which is passed as a string, because it has to be resolved by this mock library with the right. It's a bit tricky how it's implemented, but anyway, whenever something calls this function from inside this class, it will actually simply use this lambda, which I define here. This is a possible use case. Yeah.
Thank you.
Would you alter the constructor of the decorated class? Oh.
Yeah, I suppose yes. You can. Well, I mean, replace with another one is easy, but change how the current one works is more complicated because you can change maybe the bytecode or you can do the abstract syntax tree changes. But I don't think it's a good idea. Just use a subclass.
Thanks.
Any more questions? Yeah, over there.
Actually, I'd like to, maybe it's not a question to you, but I think anybody looking for a practical example for using decorators, it would be, for example, the web application. As for example, Django application, if you want to limit the access for some views, specific views, you just add this decorator is authorized, or is logged in, or is a group user of such a group, then you can give this specific argument for a context. I think it is one of the common use cases. So if anyone was wondering if it's practical, it is. It's really useful.
Yeah. In Bottle, for example, you define all the routing with the decorator on top of the
routing,
function.
yeah, for URLs.
That's another thing.
Thanks.
Thanks to you.
Questions? Call it a day? Yeah. Okay, thank you again.
Thanks.
Thank you, Andrea.